Git is version control for your automation code. And in a professional environment, using Git is not optional. When your Python script pushes a configuration change to 200 routers and something breaks, you need to know exactly which version of the script ran, what it changed, when it ran, and who triggered it. Git gives you all of that. The 200901 exam tests Git directly in Domain 1. So let's make sure you have a clear mental model of how it works. Git is a distributed version control system, which means every copy, every clone of a repository contains the complete history of every commit ever made, not just the latest snapshot. There's no single point of failure. If the central server goes down, every developer with a clone has the full history. Look at the workflow pipeline diagram on screen. It shows 4 zones from left to right, and understanding this pipeline is the key to understanding Git. Zone 1, the working tree. That's your file system, the directory where your Python scripts live, and where you're actively making edits. Zone 2, the staging index, also called the index or cache. This is Git's preparation area. You explicitly choose which changes to include in the next commit. Git add filename.py moves changes from the working tree into the staging index. Git add.stages all changes in the current directory and its subdirectories. Zone 3, the local repository. Git commit -m descriptive message takes everything currently in the staging index and saves a permanent immutable snapshot to your local repo's history with a SHA-1 hash identifier. The commit message should describe what changed and why. In present tense, add device inventory function, not added or adding. Zone 4, the remote repository, GitHub, GitLab, or your organization's internal Git server. Git push origin main uploads your local commits to the remote branch named main on the remote named origin. Other team members can then access those commits. The reverse flow, Git pull fetches new commits from the remote and merges them into your current local branch, bringing you up to date with changes your teammates have pushed. Git clone creates a brand new local copy of a remote repository, including the complete commit history. Use this to start working on a project for the first time. Think of Git commits like save points in a game. Every commit is a snapshot you can return to. If a script change causes an outage, you git revert or git checkout to a known good commit and immediately recover. In network automation, that rollback capability is your safety net. And it's one of the branching is the workflow mechanism that lets you develop new features, experiments, or fixes in isolation without touching the stable working code on your main branch. This is critically important in network automation because the code on main is what's running in production. You cannot afford to push broken, half-finished work there. Here's how it works. You start on main, your stable production branch. You create a new branch with git branch feature /add SPF. The naming convention feature /description or fixed description is common. Then switch to it with git checkout feature /add.aspf, or do both steps in a single command with git checkout -b feature /add.aspf. Now you're on the new branch. Any commits you make here are completely isolated from main. Your teammate's main branch is unaffected, production scripts keep running, and you can experiment freely. When the feature is finished and tested in a lab, you switch back to main with git checkout main and git merge feature /add SPF. Git creates a merge commit that combines both histories. In professional team environments, and network automation almost always involves a team, you don't merge your own branch directly to main. Instead, you open a pull request on GitLab or a merge request on GitLab. A teammate reviews your code diff, catches logic errors or security issues, suggests improvements, and either requests changes or approves. Only then does the code merge to main. This peer review gate is one of the most valuable practices in all of NetDevOps. Before you push anything, run git diff to see exactly which lines changed in your working tree versus your last commit. It's a fast, low-friction sanity check that catches accidental changes before they become public. Now, .gitignore, and I want you to pay especially close attention here because this is a security issue, not just a hygiene issue. A .gitignore file placed in your repository root tells Git which files and directories to never track, never stage, and never commit. The three most important entries for every network automation project: .env for your API keys, passwords, and other credentials. Never ever commit credentials to a repository, especially a public one. .venv/ for your Python virtual environment directory. That's megabytes of installed packages that don't belong in version control. And Pike for Python bytecode files that Python automatically generates and that have no value in version control. If you accidentally commit a .env file containing API credentials to a public GitHub repository, you must rotate those credentials immediately. Bots scan GitHub for leaked credentials within minutes of a push. Last concept, Git tag version 1.0. Tags create a permanent human-readable label pointing to a specific commit. In network automation, tagging is how you correlate your code version with an actual production deployment. When your CI/CD pipeline runs a deployment, it tags the commit with a version number and logs which tag was deployed to which devices and when. When something breaks in production, you pull up the tag, see the exact script that ran, and know precisely where to start the investigation. Tags turn your commit history from a general log into a precise audit trail. Final knowledge check for Module 1. 3 questions covering data formats and Git. Take a real moment to retrieve the answers from memory before reading on. The repetition is what makes it stick. First question, which Python function safely parses a YAML string into a Python dict? The answer is YAML.safe_load from the PyYAML library. Not YAML.load. That's the unsafe version that can execute arbitrary Python code embedded in a crafted YAML file. And it's a genuine security vulnerability. YAML.safe_load restricts parsing to safe constructs only. Use it every single time, no exceptions. Second question, a netconf response arrives as XML. Which standard library module and which function do you use to parse it into an element object? You import xml.etree element tree aliased as et by convention from Python's standard library, and you call et.fromString xml_string. That returns an element object representing the document root, which you then navigate with .find to get the first matching child element, .findAll to get a list of all matching children, .text to access text content, and .get to access attribute values. Third question, you have API credentials stored in a .env file in your project directory. What Git file do you use to ensure that file is never accidentally committed to the repository? A .gitignore file in the repository root. You add the line .env to .gitignore, and from that point on, Git completely ignores that file. It won't appear in Git status, it won't be staged by git add, and it will never appear in a commit. If your .env file ever does end up committed to a public repository, rotate every credential in it immediately. Bots scan GitHub for exposed credentials within minutes. Hopefully, you got all three. You've completed Module 1, the full foundation is built. Module 2 is where we start making live API calls and putting all of this into practice. Outstanding work. Let's keep moving.